Hi, welcome back, Common Core Algebra II. Today's lesson is 6.5, Factoring by Grouping. So until now, we've factored three different ways. We've factored out the GCF, we've used DOPS, or the difference of perfect squares, and we've taken a trinomial and factored into two binomials. We even factored completely, which is basically using two of these different types of factoring. So today what we're going to talk about is what happens when we have factoring where we're not starting with a binomial or a trinomial, we're starting, or even of degree 1 or 2, we're starting with degrees of 3 or more, which means we're starting with x cubes or x to the 4th powers. So we do that by what's called factoring by grouping. So in this exercise 1, remember, I always like to try to do it the reverse way before we start doing it the more difficult way. So in exercise 1, factor a binomial common factor out of each of the following expressions. Write your final expression as the product of two binomials. So if we take a look at A, well, you can see how you have 2x plus 1, and this is a little different because we're used to having factors being just numbers as GCFs, but in this case, if I factor out a 2x plus 1, I can put my 2x plus 1 out front, and then what I can do is, remember what that means. It means we're going to factor out that 2x plus 1 out of each one. And then what are we left with? We're left with x plus 7. Kind of cool, right? Moving on to B. Same scenario. In this case, if you take a look at it, we have x minus 2. So we're going to put our x minus 2, which is common to both terms of our polynomial here, and we're going to divide out that x minus 2. And then what are we going to get here? We're going to be left with 5x subtract 4. So hopefully you're getting the idea how this works. So on the bottom one on C, you can see how the x minus 7 is what's common, right? So if you factor out the x minus 7, and sometimes it is helpful to do this. I'm not saying all the time, but if you do this, then these cancel, and then what are we left with? Remember, now this means it's going to be x plus 5 plus x plus 1. So this we need to do one more step and do some combining of like terms, and you get 2x plus 6. All right, we're going to have the same situation here. When we pull out the x plus 4, what are we going to be left with? 2x plus 8 minus, now beware of that negative sign here, because when we take out that x minus 2, I'm just going to leave that in parentheses for the time being, because I feel like that negative might be missed. So we're left with the x plus 4, and then we have 2x plus 8 minus x plus 2, and you could have skipped that step, but sometimes I find when we skip steps, we make mistakes. Myself included, by the way. All right, so 2x minus x is x, and positive 8 plus 2 is 10. Okay, so write down what you need to, and we'll take a look at exercise 2. So 2 says, write an expression, x plus 3 times x minus 4 plus 5 times the quantity of x plus 3 as the equivalent product of binomials. To test this, test this equivalency with x equals 2. So I think what they kind of want you to do here is factor out that x plus 3. So basically, let me write this down first. Let's start this. X plus 3, this is exactly what we're starting with. X minus 4 plus 5 times x plus 3. And then what they want us to do is factor out the x plus 3. So if we factor out that x plus 3, what do we have left over? We have x minus 4 plus 5. So this becomes x plus 3 times x plus 1. All right, and they're saying to check it with x equals 2. So that means wherever there's an x, I'm going to put a 2. So I get 2 plus 3 times 2 minus 4 plus 5 times 2 plus 3 is equal to 5 times negative 2 plus 5 times 5, I almost said 6, times 5. So this turns out to be negative 10 plus 25, which is 15. Now let's test it with our revised version over here. And here I'm going to do 2 plus 3 and 2 plus 1 is equal to 5 times 3, which is also equal to 15. Okay, in exercise 3, it says consider the expression 2x cubed minus 6x squared plus 5x minus 15. Justify each step below with one of the three major properties of real numbers. This i.e. means, in other words, the commutative property, the associative property, or the distributive property. So, as we move from this one to this one, what did we do? Nothing changed places. The only thing that changed were parentheses. And anytime we regroup, that's called the associative property. All right, so now what happens from here to here? What changes? Oh, they factor out the 2x squared out of the left side and the 5 out of the right. And so whenever they're distributing something or factoring something out, that's the distributive property. And then here what they do, once again, now this is kind of an opposite way, but now they factor out the x minus 3, which is also the distributive property. All right, it's really important to be able to justify why we do things in mathematics. All right, and using the properties of real numbers is one of the ways we do that. All right, so exercise 4 talks about, let's see what it says in the green here. We will factor by grouping. We will first extract common factors from pairs of binomials in 4-term polynomials. If we are lucky, we are left with another binomial common factor. So that's what we're going to do here. So this is what we've been working towards. Working towards these more complex polynomials. The A is a degree 3, B is also a degree 3, C is a degree 5, and D is also a degree 3, which means that's the highest exponent that you have in that particular polynomial. So realize we're not solving anything. There's no equal sign here. So they're basically saying to completely factor this. So what we're going to do is we're going to break this up. Notice it's in descending order, which means we start with the highest degree and we go from x cubed to x squared to x to the first to x to the 0, which is basically your constant. So we're going to take a look at this piece first right here. And what's common to it? X. So we're going to pull an x out of that, and then what are we left with? 3x, I'm sorry, x squared is common to that. So we're left with 3x plus 2. Then what we're going to do is we're going to work on this part right here. So notice how there's a minus in here. So I'm going to put a minus sign here. But beware when you use that minus sign, because now if you look at 27 and 18, I can kind of see that 9 is my greatest common factor. So if I take out a 9, I'm going to end up with a positive 3x and a positive 2. Now, if by chance you got a negative 2 there, you might recognize that that would not be a common factor then. We wouldn't have that binomial common factor. And right then and there, hopefully you'd realize you made a little bit of a mistake. So now we're going to factor out that 3x plus 2. And then what are we left with? We're left with x squared minus 9. It's not x squared minus 9, it's x minus 9. Sorry about that. Because I was thinking we'd be able to factor that some more. No, it is x squared minus 9. So we can factor this again. All right, so we have x squared minus 9. So one more time, we can do 3x plus 2. And you can factor this again into x plus 3 and x minus 3. Because it says completely factor, so you better make sure that you have nothing else that you can factor when you're done with these. All right, you might want to pause and take a look at that one. If it's a little sketchy, we can go on to B, and hopefully you'll start picking it up. So again, the first thing we're going to recognize is that this is already in descending order in B. We have x cubed, we have x squared, we have x, and then we have our constant. So I'm going to kind of break this up, and we're going to take a look at this piece right here. So again, now I can take out an x squared, but I can also take out a 9. So I can take out a 9x squared, that's my greatest common factor. And then what am I left with? 2x plus 1. Now that minus sign, now if you take a look at this second piece here, I hope you're realizing that, wow, that's pretty close to what I have. So if I put a minus sign here, I can create 2x plus 1, right? You can do it a quick check and say -2, -1, like if you, in Algebra 1 sometimes we did this, -1 times positive 2x is our -2x, and -1 times a positive 1 is our -1. All right, so now factor out that 2x plus 1. It doesn't always have to be first. You can put it second. And then we have 9x squared minus 1 left over. And again, we have one more step we can take because 9x squared minus 1 is a DOPS, the difference of perfect squares, which will result in conjugate pairs. So 3x plus 1 and 3x minus 1. Now, how could you check this? Multiply it out. If this is an important question, if it's on a test, if it's a quick poll, if it's something that's important that really counts to you, you might want to take a minute and just give it a quick check. And believe me, it won't take long. Okay, we're moving on to C and D now. All right, we're going to follow the same routine we have been. So we're going to take the first part right here. And what can we take out? We can take out an x to the third power. And we're left with x squared plus 4. Right? And the next part we can take out, we can't take out an x, but we can take out a 2, and we get x squared plus 4. And if they're telling you to factor this, you're certainly hoping that you're going to have a common binomial factor here. And we do have, now this time let's do an x cubed plus 2. We'll put that first, and we'll put the x squared plus 4 last, because the commutative property says we can switch these around and they are equivalent. Now don't make the mistake, this is not a DOPS, because I'm going to remind you that this is a plus sign right here. There's no way that you can factor that into conjugate pairs if you have a plus sign. All right, that's why it's called the difference of two perfect squares. So at this point, we're done. That is our answer. All right, so how about this one? I'm going to take this piece first, and we're going to factor out 5x squared, and we're going to be left with, let's say, x plus 2, correct? Plus 20, and then we have x plus 2. I'm always happy when I get that common binomial factor. So then what am I going to be left with? The x plus 2 times 5x squared plus 20. So again, I can pull out a greatest common factor here and make this x plus 2 times 5. I'll put the 5 out front here, and I have x squared plus 4. Again, it's a plus sign with that squared plus 4, so I can't really touch that. Now, I had to take that 5 out all the way over here, but I want to remind you that right here, you could have recognized that 5, 10, 20, and 40 are all multiples of 5, so you could have started this with factoring out that 5, plus 2x squared plus 4x minus 8, and then followed that through, and you would have come out with our same answer down here. All right. So I'm going to tell you, be careful when using factoring by grouping. Don't force the method when it does not apply. All right, this can lead to errors. It's the same situation that we were talking about here. Don't think that you can take this into conjugate pairs because it's got to be the difference of two perfect squares, not the sum. We have nothing that's called SOPs. All right, and this last question is just an error analysis. It's saying consider this expression and explain the error that was made in factoring. All right, and how can you tell that error was incorrect? So basically from here to here, is that perfectly done right? They factor out a 2x squared and we're left with x plus 5. So this piece is good right here. Then they factor out, and then I'm now looking at this piece, and they factor out a 7. So this piece right here I'm good with. And hopefully you are too. But now what do they do now? Okay, I see what happens. They kind of assume that what they did was right. All right, you can't fudge it. So this and this are not common binomial factors. So at that point, when we get to this point right here, we're done. We can't do anymore. So the person who did this was incorrect. They tried to figure out that x plus 5 and kind of put them together, and Lord knows what happened from there. It just got crazy ugly. But so at this point, you would make sure that you are explaining why this is incorrect. Boy, that's a long bell. But with that, we're done with this lesson. So at this point now, I would like you to make sure you understand what's going on here. Maybe take a quick look at it one more time and make sure that those last exercises that we did in exercise 3 are really, hitting home with you. So until then, make good choices and I'll see you tomorrow.